Okay, pre-calculus lesson, linear functions and slope. So, what are we going to be doing in this section? We're going to go ahead and be calculating slope. We're going to be calculating the equation of the line that's just basically given various information, and we're going to be doing some graphing as well. So, speaking of graphing, we're going to be using the graphing calculator in some parts, and just learning some of the properties and getting good with our technology. And then we're going to be taking a look at everyone's favorite word problems. Okay, and the carryover from your previous mathematical classes, if you will, we're going to go ahead and have to know slope, and just a review of all of the forms that a line could be written in. So we're going to dive into those at various points in the video. So first up is that let's go ahead and take a look at what we do with fractions in peculiar situations. Okay, well, we have fractions that are going to be written horizontally there. One of the quickest ways, I think, to do these out is this method. I know that we can find common denominators, but this is how I usually do them in my head if need be. So what I do is that I take these two numbers and I multiply them, and I go 4 times 3, which is going to give me 12. And then I go ahead and I take the sign, whatever sign is in the middle here. So here we have a subtraction sign. And then I do 5 times 3 this direction here. That's going to give me 15 all over. And this last step, which is going to go ahead and be 5 times 4, which is 20. And so when I subtract these out, 15 from 12 is going to give me a negative 3, and so I have a negative 3 over 20 for my solution to that first one there. It's just a trick that, again, used where you can go ahead and get good at doing these fractions out in your head, and then later on in the course when we move over to radians, it also helps speed things up. So compound fractions, when we got fractions on top of fractions, which happens sometimes, we want to go ahead and vision them as written like that, because that's basically what it is. This guy divided by this guy. And so from here, we know that we're dividing fractions. We take the second one and change the the division sign to a multiplication sign. We take the reciprocal of the second fraction and then just multiply straight across. So I get 2 times 7, which is 14, and that doesn't look like 4, does it? Ugh. So 14, and then 3 times 5, which is 15, and that is my solution. So at any rate, let's dig into the meat of the course and see where it takes us. Okay, so if we're finding slope, and we got 2 points here that are going to go ahead and be on a Cartesian grid, let's go ahead and plot those points out real quick. So that's going to be a negative 2, 0, and a 3, 1, and we want to find the slope. Now, when we have just points that are floating in space there, we can go ahead and actually just count up and over to the next point. So you want to start, if you're going to do it that way, you always start at your leftmost point, and you do the direction up or down, and then right to the rightmost point. And so it looks like I went up 1 and right, 5? And so my slope is going to go ahead and be 1/5. However, if we need to go ahead and use this formula, the slope formula there, and you can just go ahead and allocate these guys as x1 and y1, x2 and y2. And remember that those little tiny numbers don't have any thing to do with the actual value, like it's not multiplying by a 2 there. It's called a subscript, and it just basically means is that both these guys are y's, for example, and they're different y's, y1, y2. Okay? So anyhow, thrown this into our slope formula, which should end up being 1/5. But let's go ahead and, for educational sake, do it out. So I got 1 minus 0 over 3 minus -2, and lo and behold, we got 1/5. So it matches. Okay. So on to the next one. Okay, this is an example where we gotta actually use the formula, because this is not going to be so nice to just to count off like we did in the previous example. In the previous example, we had nice integers. This one, not so much. So we'd have 4 comma 0, and then we'd have 2/3 and a -1/2. So about 2/3 would be in -1/2. I don't know, something like that. And you can see it's not going to be so easy to count over in this direction. It might be easiest for us to go ahead and just put it into the formula and see what shakes loose. Okay, so let's set up our formula. Okay, so I set everything up, and it looks like when we're going to go ahead and do the arithmetic with this, we're going to go ahead and get these values here, and I did the real quick arithmetic down over here, so you didn't have to just sit and watch me do it. And so we need to clean this up, and so we are going to go ahead and apply that prerequisite skill of a fraction divided by a fraction. So we're going to get -1/2, and we're going to multiply it by the reciprocal, which is going to be this guy. There. And that is multiplying straight across. We're going to have negative times a negative positive, so it looks like we got 3 over 20. Okay, so that's going to be the slope. A little bit tougher to find than the previous one, but still, if you have you know what to do with the fractions in different situations, we're sophisticated enough that we can get it figured out. So that's how you do that, and on to the next. Okay, so here's some generalizations about slope, and we're going to go ahead and just draw some arbitrary lines through these guys. I shouldn't say arbitrary, but it's going to go ahead and model what a positive slope, a negative slope, and the whole deal is. Now, first thing about slope is that you want to read it from left to right. So when a slope, so say for example, I'm going to do a positive slope here. This is red. Like say you're driving in a car, you're riding a roller coaster, whatever. You read it from left to right. Okay, you don't read it in this direction. That's bad. That you don't want to go ahead and do that out. So, reading it from left to right, obviously that line goes up, and a negative slope is going to go ahead again. Reading from left to right is going to go down. Now, an undefined slope, we're going to go ahead and find out that that is just going to be a vertical line, and a zero slope is going to go ahead and just be a horizontal line. Now, why is a slope going to go ahead and be undefined? A vertical line. So you notice that slope is going to go ahead and be change in y over change in x. Now, if we look for the undefined slope, we're not changing or we're not moving x in either direction. So no matter what the change is in y, the change in x is 0. So anything divided by 0 is going to go ahead and give us undefined. And likewise, we're not changing in y at all with a 0 slope. Okay, and so if we had change in y over change in x, we're not changing at all in the y direction. So we'd have 0 divided by the change in x, which something divided into 0 is always going to go ahead and give us 0. So those are the reasons why the vertical line is going to have an undefined slope and a horizontal line is going to have a 0 slope. Okay, so what are the equations of horizontal and vertical lines? And so basically, they're pretty straightforward. Is that a horizontal line, okay, is you notice that it is going to pass through the y-axis at some value c. Okay, and so in fact, if we write this kind of slicker, it's going to go ahead and pass 0c, where this guy is going to be c. So since it hits the y axis, we're going to go ahead and just say y equals c. So it's always going to go ahead and be y equals some constant, some number. Okay, and the same deal for a vertical line. Okay, and the vertical line is going to be hitting here at c comma 0, and it hits the x-axis, so we just leave it as x equals c, the constant. Okay, so for example, this might be, just guessing, for example, that might be y equals 3, and this one, it's on the negative side, so it might be x equals a negative 3. Okay, so we're going to be expected to know how to go ahead and do that if we need horizontal or vertical lines and graph them out. Okay, in this part, we're going to go ahead and take a look at the point slope form of a line. So let's load up the point slope form from our prerequisite skills here. Okay, so that's what it looks like, and I know that a lot of us don't really use this. We like slope intercept. We just kind of like, grew up learning that form. But there's going to be times, especially in calculus, where this is going to be a little bit more slicker and easier for us to do out. So first things first is that we always want to go ahead and, just a quality of life thing, is that I always like to call these the 1s and 2s and load them into the second part of the y's and x's, just to go ahead and keep the variables that I'm going to leave, the y sub 2 and the x sub 2, as positive. Okay, in this case we have the slope. Remember, mountains have slopes, m slope, etc., etc. So yeah, let's go ahead and plug that in and see what happens. Okay, so after plugging it in with this step right here, just putting the values that I allocated, the x1, y1, and the slope, and then some slight cleaning up, this is going to go ahead and be the point slope form of a line. In calculus, oftentimes you could just leave it like that. That's an acceptable answer form for the AP test. However, most students like to go ahead and put it back to their wheelhouse, which is the slope intercept form, and so to do so, we just have to use some quick algebra to knock this down. Okay, and let's see, let's move that 2 on over there, and it looks like for our y equals mx plus b form, that would be it. Okay, so that's how we do that, and on to the next. Okay, in this part, we're going to go ahead and take a look at the point slope form of a line. So let's load up the point slope form from our prerequisite skills here. Okay, so that's what it looks like, and I know that a lot of us don't really use this. We like slope intercept. We just kind of like, grew up learning that form. But there's going to be times, especially in calculus, where this is going to be a little bit more slicker and easier for us to do out. So first things first is that we always want to go ahead and, just a quality of life thing, is that I always like to call these the 1s and 2s and load them into the second part of the y's and x's, just to go ahead and keep the variables that I'm going to leave, the y sub 2 and the x sub 2, as positive. Okay, in this case we have the slope. Remember, mountains have slopes, m slope, etc., etc. So yeah, let's go ahead and plug that in and see what happens. Okay, so after plugging it in with this step right here, just putting the values that I allocated, the x1, y1, and the slope. And then some slight cleaning up. This is going to go ahead and be the point slope form of the line. In calculus, oftentimes you could just leave it like that. That's an acceptable answer form for the AP test. However, most students like to go ahead and put it back to their wheelhouse, which is the slope-intercept form. And so to do so, we just have to use some quick algebra to knock this down. Okay, and let's see. Let's move that 2 on over there, and it looks like for our y equals mx plus b form, that would be it. Okay, so that's how we do that, and on to the next. Okay, next is going to go ahead and be this slope-intercept form, and we are going to go ahead and take a look at something that is given in general form, and then we're going to put it in slope-intercept form, and then we're going to go ahead and take a look at how to graph that thing out. Okay, so first things first, general form. We got the x and the y's on both sides, and we have a constant on the other. Sometimes it's very convenient, especially when we're doing system equations, to write things like that for algebraic purposes. So, but what we want to do is that we want to isolate y. So to do so is that I'm going to subtract 3x from both sides, and that's going to give me a negative 4y equals a negative 3x plus 10. Now again, the reason why we're doing this is that slope-intercept form is y equals mx plus b. So we want to go ahead and we want to have the x, right, and the y, with the x on one side and the y all isolated out. That way we will know the slope, okay, of the line, and we'll know the y-intercept. So next step is to go ahead and divide everything by negative 4, and also clean it up as things go on, or as needed. So you go y equals, and over here a negative divided by a negative is going to give you a positive, so you would have 3/4 x. A negative divided into a positive is going to give you a negative, and I want to reduce that down, so I would go ahead and have 5/2. Okay, so this is going to be the equation in slope-intercept form. And the information that's asked for is this. What is going to be the slope of the line? The slope of the line is in the m, or position, if you will. And so the slope is going to be 3/4, and the y-intercept is going to be a negative 5/2. Okay. Now, graphing this is going to be a little bit difficult because of the peculiar fractions and whatnot. So I'm just going to go ahead and erase things out and show you a quick way to graph things in general form using intercepts. Okay, so if we're asked to graph this this line right here, one of the easier ways to do it with a reasonable amount of accuracy is just do it by intercepts. And so, if I want to find, for example, the x-intercept of that that line, then I can go ahead and just let y equal 0. And so we would just go 3x minus 4 times 0 equals 10. So the 4 times 0 is just going to go away. Divide each side by 3, and x equals 10/3. So the point that I'm going to go ahead and the x-intercept is 10/3, 0. Now the same thing could be done for the y-intercept, except we just let x equal 0 and solve for it. So I'm going to go 3 times 0 minus 4y equals 10. Okay, and this is going to go out, and we divide each side by 4. And much like we revealed in the previous video, that the y-intercept is going to be a negative 5 over 2. Okay, so we would write that as 0, negative 5 over 2. So to go ahead and graph those out with just using this information, just using the 2 points, getting an idea of what this is going to look like. So 10 over 3 is about 3 and 1/3, so something like that. And a negative 2.5. So it looks like this is going to be a pretty good graph of that line. Again, not perfect, but we got an idea of what that is going to go ahead and look like. And we do have some good information that is that the intercepts, which is important in pre-calculus. Okay, so next video we're going to start taking a look at parallel lines and perpendicular lines. Okay, the first thing we're going to go ahead and do here is we're going to take a look at parallel lines. Now, we know that parallel lines, and this is a parallel line example here, they're going to have the same slope in a Cartesian grid, or on where you're graphing, okay, in 2 dimensions. So that said, is that we need to go ahead and, if I want my line to be parallel to the given line and go through a point, I'm going to need a slope, because it says parallel lines have the same slopes. So that basically means it would be real helpful if I knew the slope of that line. Okay, so let's go ahead and find it. So using what we have learned, we set this up. Okay, and then we want to isolate y to get x all by itself. So I'm going to do that real quick. I said x all by itself. I should say x over on the right hand side, so I misspoke. My apologies. So just doing out the algebra real quick. Okay, and we're going to divide through by 3, negative 3 rather. Okay, so I get y equals 2/3 x minus 3. Okay, and so I know that the slope of the line that's given is going to be 2/3. So we're going to borrow that, and I'm going to use the point slope form that we looked at in previous videos to go ahead and find the rest of the equation. Okay, because again, we just have the slope. What we need to do is go ahead and find the equation of the line that's going to go through these points. Okay, so let's go ahead and set that up. Okay, so here's the, again, as promised, point slope, and I dropped in the values that the line has to go through. Oops, I'm losing that negative there by circling it too much. And so those, just to go ahead and draw lines to where they went. So the y went here, okay, the x is over here, and then the slope went right there. Okay, so that said, let's clean this up and see what the equation is. So let's go ahead and put this in slope-intercept form. So, all right, so we're going to have this, and I'm going to clean up inside of the parentheses first. And it looks like we're going to have that. And we're going to use the distributive property here. Okay. And let's see. We're going to go ahead and get that. And then add 3 to each side. And we get this guy right here. So this is the line that we suspect is going to go ahead and be parallel to this line, okay, that we went ahead and put in slope-intercept form in the previous steps in red. So let's go ahead and graph these lines and see if it's reasonable. That is that they look like they are parallel. They're doing what they're supposed to be doing. Okay, so here they are graphed out. The best that my my iPad could go ahead and make the lines as straight as possible. But at any rate, yeah, you can see that this is going to go ahead, and this is this guy right here, and then this one is this guy over here, and you can see that they look parallel. If I had, just a paper and pencil and whatnot, I could probably be, funny enough, a little bit more accurate, but these lines kind of snap to different things while I'm writing them. So that's how we go ahead and do the parallel lines, and we're going to take a look at perpendicular lines next. Okay, so now we're going to go ahead and take a look at how to find lines that, or a line that's going to be perpendicular to a given line. And a couple different things. Number one is that we want to make sure that we know what perpendicular lines are, is that they make 90 degrees at intersection. Okay, so that this basically means is that if we have like this and this, we're going to have a 90-degree angle there. Okay, and number two is that they have slopes that are going to be opposite reciprocals. Okay, so what that means is that puts us in a position, again, if we read the prompt here, is that line, we're going to have to find the slope of it, take the opposite reciprocal of it, plug in the points that are going to be given to it, and the slope that is the opposite reciprocal of the original into the point slope form, and then solve it out. So let's go ahead and do that. So I'm going to work on algebraically revealing the slope of my line over here. And sometimes I know that we're pretty sophisticated as far as pre-calc folk goes, and so I'm going to start going a little bit faster as far as the algebra goes. Okay, so we know that the original line here has a slope of a -3. So to go ahead and find a slope that's a reciprocal, opposite reciprocal, we take the negative, turn it into a positive, and we put the 1/3, the 1/3 to go ahead and make a 1/3 slope. So this is the one that we're going to be using in our point slope form. So I'm going to go ahead and set up the point slope form, and let's see what we get. Okay, point slope form, loaded in all the values as seen in the previous video, and so let's go ahead and knock down the algebra with that, kind of using the distributive property and everything all at the same point here. 3, that's x plus 1, subtract 6, we got ourselves this guy. Okay, so this is going to go ahead and be the line that is perpendicular to this, which we wrote as that. And so we're going to go ahead and graph these out real quick and see if it does what we say it should do. Okay, so there's the lines that are graphed out, and I believe we have a 90-degree angle right here. Okay, so looks like they did what they were supposed to do. And yeah, from there on out, that's how we're going to go ahead and tackle those perpendicular lines. So on to some word problems, shall we? Okay, now this type of problem is going to go ahead and walk us through just some strategies to go ahead and take a look at building a linear function based on some information given in a scenario. Okay, so what we want to kind of do is just break this down and maybe take notes as we read through this thing. Okay, so it says during 2009, a brand new Comic-Con Hamster Man collectible sold for $25.50. So in 2009, okay, we went ahead and it was $25.50. Okay, in 2014, the same collectible was sold for $47.25. Okay, so let's go ahead and so we got that off to the side here. It says write a linear equation, okay, to model how much a collectible is worth with respect to years. Okay, so we are looking at taking a look at this. Is that we want to plug in years, okay, years, and get a value out. Okay. And then we want to use it to make a prediction about this, how much it's going to be worth in 2017, which was, a couple of years ago. But anyhow, the spirit of the problem here. So let's go ahead and start breaking things down here and looking at strategies. Okay, so first things first is that what I like to do is just kind of like set up how I'm going to set up the X and Y's here. So years is time, and value we can call V. So since I'm plugging years into something, this, and I'm going to leave this purposely incomplete, this is going to go ahead and be years, and this is going to go ahead and be value. Okay, now here's the deal. I can't believe I misspelled years again. Oops. So, or can I believe it? So this is going to go ahead and be years, but what we want to do is that we want to make sure that we're creating a X value or time value that makes sense. So what we're going to do is that since this hamster man did not exist prior to 2009, okay, is that we're going to go ahead and say years from 2009, okay, and then that's going to go ahead and that will put our t value like right here at 0, and then we'd have 1 and 2, etc., etc. And that's going to be way more convenient than this business of trying to go ahead and put 2009 into an equation. All right, so let's take a look at something we can do now that we set up the parameters. Let's make kind of like a little graph here, okay? Doing the best that we can, a sketch that's going to help us make accurate calculations. Okay, so I just kind of set this up so I can visually see what's going on with the price of this this little statue or whatever collectible is going to go ahead and be doing throughout the years. So since this is years from 2009, we know that if I start here at 0, okay, and I start going this way, it looks like the price is going to increase. So let's plot some points and label them so it's easier to work with, okay? So the first point that I want to plot is going to be 0, and then it is going to be, let's see, 0, comma, 25.50. So that basically means is that 0 years from 2009, because it is 2009, it was worth $25.50. Okay, so it looks like 5 years later, where we'd have 2010, 11, 12, 13, 14. So at the 5, we want to go ahead and make another point, and that's going to be, let's see, 30, 47. So trying to aim this up here. There we go, something like that. And so that is going to be 5, comma, 47.25. Okay, so now we have those magic 2 points where we can go ahead and build a linear equation from that. And so it looks like we're going to need the slope, we're going to need some other stuff. So let's go after what we have first, which is going to be the slope. Shouldn't be too hard to find, and I will set it up. Okay, so the slope, it looks like when we do the calculations, we're going to have 2175 over 5, which basically means it's going to gain $21.75 every 5 years. However, since this is a money type problem, writing the slope with the denominator of 1 might be the best, because we could go ahead and get the value per year rather than over a set of years. And so after we do that out, we end up with, looks like it's gaining $4.35 per year. Okay, so what we can do then is that we can start dividing our value, or our variables. And before we're going to have, we talked about a little tiny bit, but just to clarify, is that I'm going to let t equal the years from, hey, I spelled it right, 2009, and v equals value in dollars. Okay, so to go ahead and do this, it looks like we got enough information to put this into the y equals mx plus b form, because we want a linear function. Okay, now let's go ahead and take a look at just placing in the correct variables and the correct numbers here. So y is going to be the value, and so we're going to go ahead and, if we're writing something that's, we want it to look kind of slick, we're going to have the value equals the slope, which is going to go ahead and be the amount it's changing per year, which is going to be a constant rate because this is linear, $4.35 times t, okay, the input value from 2009, plus, and what's kind of neat about this problem is that we know the y-intercept already because it was given. That's how the way that we lined it up. So y-intercept is going to be, pardon me, the starting amount of how much this thing was, okay, which is going to be 2550. Okay, so this is going to be the linear function that is going to help us make predictions about what we went ahead and about the hamster man statue as time goes on. Okay, now the next thing that it asks is that it says use that to make a prediction about what's going to be in 2017. So what we can do is that we say the value, whatever that is, times $4.35. Now years from 2009. Okay, so from 2009 on over to 2017, I believe that's going to be what, 8 years? Plus this guy right here, 2550. And at the end of the day, our prediction for the 2017 total is going to be, looks like it's going to be $60.30 in 2017. Okay, so if we were to complete the line process right here, if it's going to let me draw a nice one, okay, so it seems that if I plug in 8, is this my graph kind of make sense here? Okay, so if we look linearly, 8, and you can tell that this is 40, 50, 60, and so it's going to come on over here, and it looks like we did pretty good as far as making this point right here. Okay, so we end up with 8, comma, $60.30. Okay, now what are the limitations? Limitations from this guy is that, for one, it's linear. Okay, and things don't often grow in a linear way. That is that from the change from year to year oftentimes is different. And so this is going to be something that we're going to look at different models in videos that are going to be coming up in the class and whatnot. But this is a way that you would do something from a linear standpoint, even though linear models sometimes are they're estimates, and there's better ways to get more accuracy as we become more sophisticated in the class. Okay, so let's take a look at one more example of what we're going to be expected to do, and I'll see you there. Okay, this next problem is kind of like the last problem that we just did. And it looks like we're given some statistics here. And so let's go ahead and just make sense of everything that's going on. So it looks like we have men's average age of first marriage. And it looks like that average age is going up from the year, let's see, probably looks like 2009 they started to pay attention to this thing, okay? Or maybe 2008 because it says over here, 2008. So we look at this and we got our graph, or I should say the bar graph here. And this bar graph is translated on over to a linear graph, okay? And you can see that this is, it seems like it's something called a line of best fit, where two of the points got picked, and they just kind of ran a line through that to make a prediction about how this trend is going when men get their first marriage or do their first marriage, okay? So that said, is that what it's asking us is that we want to write a linear function of men's average, let's see here, average marriage with respect to years after 2010. Okay, and so that said, we're going to wind up and do the same thing that we did last time, and it looks like since this is from 2008, so that 2008 would be 0 over here on this graph, so it looks like we'd have 2009, 2010. So, kind of putting the information aside here from the graphs, at 2010 we had, it looks like the average age was 28.2, and 2 years later, which is going to be 2012, okay, it looks like we're going to have 28.6. Okay, so those are our numbers, and so let's go ahead and find the slope like we did in the last example. Let's build the equation, define our variables, and all that other good stuff, okay? So let's start off with defining the variables. Okay, so I went ahead and I defined t, which is going to be this axis right here, the x-axis, as time in years after 2010, and then the y-axis is just going to be the average age of the male that is getting married. And so therefore, let's go ahead and find our slope using those 2 points. Okay, so the slope right here, we're just subtracting the y values, which is going to be subtracting this guy from that guy, okay, which we did right here, and then over the 2 years. So it looks like the average age is increasing 0.4 years every 2 years, okay? And for these type of problems, we like to go ahead and, especially if we got a fraction that is a little bit messy, it's okay to go ahead and put that in decimal because it's a little bit easier for the reader to read, for everyone to comprehend if we just put it in the average age per year. And so dividing this out, we end up with 0.2 age increase per year. Okay, so that's going to go ahead and be our slope. And the points themselves we already have to go ahead and put on in, and so we're going to use one set of these this data points in our next equation, and then simplify it up so we could answer some of the questions here. Okay, so here we go. We're going to build that equation that we're looking for. And let's do, I'm going to use this point right here. Now, we could use either one of those. Will work out because all those 2 points are guaranteed to be on the line because we're using them. So I'm going to use a smaller point, just a quality of life thing. So I go y minus, and then your 28.2 equals 2/10. And then we got x minus 2. Okay? Now, so this would be fine if we were to ask to go ahead and leave it into the point slope form. But let's go ahead and put this in slope intercept form, just so it resembles more of a function. Okay, so here we go. I got y equals, and basically this is going to be just doing some of the algebra real quick. 0.4. Okay, and so I'm going to add 0.28 to each side. That guy right there, and get. Looks like 27.8. And then I'm going to go ahead and finish it up and replace my defined variables in there just so it's easier for me to go ahead and read. So we got the average age is going to be A equals 0.2t plus 27.8. Okay, so it looks like by doing this out, we can also make an inference that a good predictor of what it was in 2008, which is the y-intercept, would be 27.8, would be their average age for their first marriage. So now let's go ahead and plug in the 2095 value, and we know that t is going to be the years after 2008, so we need to do some little bit of subtraction, load it in, and then calculate out. So let's do that. Okay, and so it looks like the difference between these two is going to be what, 87 years? Okay, ooh. And so we're going to go 0.2 times 87, and then we're going to tack on 27.8 years after that. And so the average age in the year 2095 is going to be a whopping 45.2 years old. Now, here is one of the things that I want to talk about, because obviously that would be kind of ridiculous unless we have some kind of like life-changing thing that's going to happen in decades to come. But, why is that reasonable? And again, we don't know the future, but it seems right now pretty unreasonable if everyone was waiting, or males waiting 45 on average to get married. It would be a much different society. And also, it kind of brings up the fact that, with these guys right here, and I'm just going to clear out the marks, is that sometimes when things are linear, it only helps to predict in a very local setting. That is that if you take it too far, you might get unreasonable answers. Like, I think something more reasonable with the graph would probably go like this, and then eventually it's going to start to plateau off, where maybe a little bit of an increase, but certainly not to the point where we're waiting till 45.2 years old to go ahead and get married here. So, anyhow, that's how you do that, and that is the last video of the first section here. And yeah, good luck with your homework, and that's how you do that. Thanks for tuning in.